Okay, example 2 is the exact same problem type as example 1. The only difference here is the way they've asked you to do it. It says perform the transformation. I'm going to move this over because I'm not sure exactly how far I have to go. But our D means dilation. Okay, remember from the other, we had capital R was rotation, capital T was translation, lowercase r was rotation, right? So capital D means dilation. So we have all our transformations. I'm really going to be focusing on dilation in this chapter. We're not going to be going back to chapter 3 stuff, just reminding you that we had some notations for that. And the dilation directions here, the operation here, dilate the figure WXYZ by a scale factor of 2 around the point of dilation Q. So it's asking us the same type of information, it's just compounding it into that little simple expression there to tell us what to do. So just like the last one, my center of dilation has been given, which is Q in this case. So I want to draw my dashed lines from Q to each point, but this time my scale factor is 2. So, since it's 2, I'm going to take the length from Q to W and I have to double it, so that means W prime is going to be out here somewhere. So when I draw my dashed lines, I want to draw them beyond the points this time. So, if I take my ruler and I'm going to put my 0 at Q and I'm going to do a dashed line through W. Go outside the polygon given. Then I'm going to twist my ruler around and go through X. Keep twisting around, I'm going to go through Y. And finally twist around and go through Z. I'm just expanding them so I know I'm going to be going double length this time to get my W prime, X prime, Y prime, and Z prime. So I'm interested in what QW is some length and QX is some length and QY is some length and finally QZ is some length. And each of these original distances from Q to each of these points is going to be then doubled, because that's what our scale factor is. So basically, if I were to make a little chart here, this is my original measurements down here. And I'll just maybe make some rows here. And I'm going to get measurements by my ruler. My scale factor is 2. So I'm going to be multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. And that will equal my new distance, which is going to be Q prime, or QW prime, QX prime, QY prime, and QZ prime. And they're going to equal some length. So that's kind of the technique that's happening. So you measure the original length from center to each point, you double, because that's what the scale factor is, to get the new measurement along there. So, if I do these measurements, start with Q again, QW. Here's QW. The distance from Q to W is, on my ruler, 1.75. 1.75 centimeters. If I double that, I get 3.5 centimeters. So, 3.5 centimeters is right there. So that is where my, right there. That's where my W prime is going to go. Come around here to QX. And I can see the QX is right at 2.4 centimeters. So QX prime is going to be at 4.8 centimeters. Oops. 2.4 centimeters, 4.8 centimeters. So there's my X prime there. My next is QY, which looks to be right at 2 centimeters. If I double that, I'm going to get 4 centimeters. So 4 centimeters is right about there. That's my Y prime. And finally QZ. Looks to be about 1.6 centimeters. So I double that, I'm going to get 3.2 centimeters. So QZ prime, 3.2 centimeters right about there. So now, I just pick my ruler up and I connect the dots W to X to Y to Z all prime. As you're doing this, try to be as precise as possible as you position your ruler. Each of these dilations, when you do it properly like this, it kind of looks like it's coming, it's either going into the picture, out of the picture kind of thing. It's kind of optical illusion type thing. Looks like three-dimensional stuff happening here. But you can see that when we get this drawn, one thing that you can expect is parallel lines. So this should be parallel to that, that parallel to that, and so on and so forth. So if they look parallel, you're probably doing it right. And again, the other way, just to verify you're right, if you measure a segment, the W prime X prime, the image in this case, should be double the original. So this is some measurement, let's just call it A. This should be 2 times A because that's where our scale factor was. So if I were to measure that, just to verify, so if I measure WX, that looks to be about 2.9 centimeters. I should bank on this being twice that, which is 5.8 centimeters, the distance from W to X prime, W prime to X prime. So if I measure it, you notice that my ruler's got an angle measure on it here. The angle measure is not being changed. So again, I'm looking at parallel lines, and you can see that right at 5.8 centimeters. So allowing for a little experimental error. So I'm not going to get perfection on these, but they're going to be really, really close. I think paper and pencil stuff instead of technology-based things, a little bit easier to be more precise, just have a steady hand when you do it.